Okay, so we're briefly going to talk about domain and range. And so here is our graph. This is our x-axis and this is our y-axis. So domain is pretty much, let me use this. Domain is how far your x points will go. And then let me color code this. Domain. And then green is your range. That's pretty much how far your y points will go. And so let's say, for example, you had this line. Let's use purple. You had this line here, y equals x. And so from here, you're going to see how far your x points will go. And so one way to think of this is, let's say this is 10. At 10, you have a point here. Let's say you want to get a point at, 200. At 200, you're also going to get an x point here. And the reason why is because your graph keeps going on forever and ever because of the arrows. Those arrows indicate that it's going to keep going forever, which means that if you get to like 2000, you're still going to have a point somewhere up here. So it's going to keep going, same way with it going down that way. And so because there's always going to be an x point, the domain is going to be, there's multiple ways to write this. You can write it as negative infinity, comma, infinity, like that. I think another way you can also write it is negative infinity is less than or greater to x, less than or greater to infinity. And you can also say all reals. This is the symbol for it, or you can write all real numbers. And then if you look at the range, so the range for the same graph, if you look at this y value, it's 10, it's going to have a y value over here as well. Same thing over here. If you go up to 100, that's still going to have a y point. And so you're just going to see how many x-axes or x points and y points you're going to have, and that domain and range is a representation of that. And so you mentioned what happens if it stops at a 3. So let's say you had a graph that looks like this, like that, something like that. And this is 3. And so with this, I'm going to say this is 5, just so we can work on domain and range. So our domain is going to be, okay, so if you go over to 4, you're not going to have, there's no x point, right? Only for when it's 3, there's going to be an x point. If you go to 3.5, there's still going to be no x point, which means that the domain, the farthest that it's willing to go is to 3. So there's 3, but if you look at the x-axis, on the left side, you'll notice that there's an arrow here. That arrow indicates that it's going to keep going. So we can assume that if it keeps going, it's going to keep going somehow, somewhere. And so it's actually going to keep going to negative infinity. So the way you would write that domain is you could do negative infinity is less than or greater to x, less than or greater to 3. Just like that. But notice how if I were to change this circle and I made it an open circle, we would have to go back to here. We'd have to go back to there, and we have to take the greater sign, like the little line underneath, away, because it can no longer equal 3. It can be 2.99, it can be 2.99999, but it can never be 3 because there's now a hole here. And so that's how the domain would be like in this case. And then if we look at the range, kind of a similar idea too. So the range is where your y points are. So if you take a look at your y-axis, you'll notice that it's going to stop at 5 right here. So that means that 5 is the highest that it can go. So you have 5, and then you'll notice that if you have a point at like negative 100, somewhere over here you'll have a point. So that means that you have a y point for that. So then you'll see that it's also negative infinity is less than or greater to x. And then in this case, it's also less than or greater to, because this can actually be 5. So actually, wait, this is not x, this should be y, because we're looking at the domain. So that's how you would do domain and range for that.